Yeah, okay, so I guess we can get started. I wanted today to be like pretty informal. Um, just there's only like four of us here, I guess. So maybe instead of me just sitting and talking for 15 minutes about um like engineering resources and that kind of stuff, I thought maybe be a bit more useful to first like source like any outstanding questions that you guys have or that you all have. Um, and and then if we have time, maybe we can talk about like some uh, realistic examples of what big companies are doing today to kind of scale up their services. And so I have a few examples lined up for that. But to start off with, maybe we can have a discussion more broadly about like, okay, well, what are you interested in? What are the kinds of things that you know what are the kinds of problems that you see as challenging and are not sure how to answer very well? Maybe we can discuss about some approaches to them. Or if you have any other questions about like what we discussed the past 4 weeks in general, we can start with that.
I had some sort of a general question, and it might not be related to the stuff that we talked before, but I was just wondering how companies, like whenever companies have a lot of data and it's really risky to have everything in one database, and or it's simply not possible to have everything in one database. How do they sort of spread all of the information that they have across several sources, so several databases?
Yeah, that's a good question. I mean, I think in some cases it's kind of obvious like what you can do, right? So like, okay, so I guess there's two components to your question. One component is like, you know, so when you talk about databases, there's kind of like two levels. Like you can have like a database itself, which is like an instance of like SQL or whatever, and then inside of that, like you have different tables to represent different data, right? So like for example, let's say you're like a store. Obviously, purchase orders are going to exist in one table that's separate than like for example, um, I don't know, employee information, right? So there's no real good relationship between those two things. And so you can say like, okay, categorically these two things are different, and so I'm going to record them in different areas. In SQL, how do you do it? Or sorry, yeah, in SQL in general, how do you do this? Like, well, you do it by creating a thing called a table where you have like rows or sorry, you have columns, different data fields, and then just rows of data with those fields. So in that sense, I guess maybe that answers part of your question. I think maybe something else that you might have been meaning to ask is like, maybe I can't store this entire table on one machine because it's very, very large. How do I split it up in that case? Well, yeah. So in that scenario, you would have this thing called a distributed database. The idea there is pretty simple. You just have like a bunch of machines that each hold a small copy of the database or a small part of the database, and they all talk amongst each other. And this is a pretty complicated problem. I think there's a course here in the school that discusses distributed systems. I took it a few years back. But yeah, it's a really challenging problem. And what you'll find is that there's like this pivotal theorem called the cap theorem. So it says you can only have two of the following three things. You can only have, you can't simultaneously be consistent, which means that all information between distributed nodes is exactly the same. Available, which means that all that every single node in the distributed system is up all the time and always able to serve data, and partition tolerant, which means that all these nodes are able to talk to each other. You can only pick two of these three things at once. And so there's a lot of research behind this. So this maybe we delve in a little bit too deeply, but does that kind of answer your question, or were you asking something else?
Yeah, that answers my question. And like, whenever we have a distributed system of distributed network of databases, is there like some sort of application that talks to all of them, and then whenever we need some specific data, we first ask, not we do not directly connect to the database, but to that application. That application then finds the info across the databases, or like how the key question is basically like how the end user, or maybe some part of the backend, knows where to search for information when the information is distributed across several systems.
Yeah, so I mean, that's also a really good question. There's multiple ways to do this, and that they have their trade-offs. So maybe we can talk about first, like what it would mean to have a central authority, like performing these kinds of operations. So let's say like I have some kind of figurehead that's sitting like at the top of the world, and I talk to her first. And I say, okay, I need this piece of data. Like for example, like I need to know what Jane bought on Tuesday, like with this purchase ID. Go out and find me that data. So let's say the database is distributed like this. In this model, there are kind of two big things you need to worry about. One is that the central authority needs to keep track of every other node in the network, and have some idea of who might contain this information, or if they don't know who might contain the information, of being able to talk to every other instance on this distributed network, right? The other thing you need to worry about is like what happens if the central guy goes down. Well, then it's not good for anybody. So it gets a little bit hairy, because what happens is like, well, I think the most obvious thing is if the central authority goes down, then you need to restart her somehow, which might be an expensive operation, and so maybe you're not able to to perform any requests for a couple of minutes or so, which is not good for anybody. But maybe a more sinister thing than this, because you can kind of remedy this. You can say, like, yeah, I'll have a backup, or whatever. But maybe a little bit more sinister thing is that she also needs to like know everything about the distributed cluster that's happening there, and you might have to talk like to every single node on that cluster, without any real idea of like who might contain this information, unless the central authority is also like someone who's responsible for setting up the entire distributed network. So it's a bit of a complicated problem. There's some other ways to do it. Kind of the one that there's a really famous method called Chord. Yeah, so this was developed by some guys at MIT, and as far as I understand, like this is still one of the most favorite mechanisms to perform these kind of distributed system lookups. And so they developed this algorithm for like if you have a set of nodes in a cluster, how can they talk to each other in a reliable way, and also be tolerant to like one going down, et cetera, et cetera. And so they mentioned like they mentioned some nice properties of this Chord thing. So yeah, I think in general, like it takes log n time to look up some piece of information, if n is the number of nodes that you have. But if you're interested in this might be worth a read. But okay, the long and short answer to your question is like there's lots of ways to do it. and there's no sort of idea of like, okay, this is definitely better than this other thing, or vice versa. It depends largely on your application and your context, what you're willing to spend time on.
That makes sense. Thank you.
Okay, so any other questions in general? Okay, so we can dive into like some examples that I'm aware of in the present day. And if you all have, you know, if there's anything that comes up that you have any question on, just feel free to blur it out and just send it in the chat. We can stop and talk about it. It obviously doesn't have to be related to whatever I'm talking about, because these are kind of just things that I'm aware of, but maybe are not so interesting to you. And if you have any suggestions on what we can talk about here as well, just let me know. But I just want to keep this kind of informal and kind of maybe a little bit more engaging and interesting than we before. Okay, so I think one thing that might be interesting to folks, again, like this is kind of my opinion. So let's kind of set the context for this. So let's say like you or I or a third are like building some kind of web application. We're probably building it for fun or for some kind of nuanced project that like might get some interaction, but certainly it's not going to be on a very large scale, right? And I think especially like at our age, the interest is on kind of getting some experience and learning how to do different things. And certainly for that, one of the most effective mechanisms is experimentation, right? And so I think, especially at the level that we are at, it is very worthwhile to kind of try different technologies and different implementation strategies and different architectures and whatever, and see what works out and what doesn't. And for us, it's relatively inexpensive to go ahead and say, let's say I try to design a service one way. Perhaps I have like one giant database where all my data is thrown in, and then I get to some critical mass, say like 1,000 users or something on my chess website or something like this. And I realize all of a sudden, well, okay, maybe it's not a good idea to keep track all the games that someone has played in the same table that I keep track of all the chat messages that they've sent to someone else, right? And so instead you decide to break up into two tables, and maybe this is a little bit of work, but as an individual who's working on a relatively small project, it's not too bad of an idea, right? So maybe another thing is like let's say you write like I don't know, a Sudoku solver or something in Python, and then you're like, well, I want my Sudoku solver to be really, really fast. It's not too much of an issue for you to go out and write in C++ instead, for example, right? So now let's like look at what that kind of process looks like at a large company, right? So let's say, for example, you are, okay, so I'm not going to name company names, but let's say you're like a company that needs to do very low latency operations for a particular service. So let's say, for example, you're a rideshare company and you need to write a service that someone wants to get a car to ride in, and they just need to click a button, and you need to match them with a ride and get that information back to them as soon as possible, right? Like speed is the name of the game here. So what are the things that you care about? Well, you care about how fast it takes you to process that request, right? You care about like how fast it takes you to get that data over the network. And yeah, probably those are the two big things, right? So the network we probably can't control that well, right? Because everyone's going to be using a different network. We can't spend too much time focusing on that. So let's think about more about our process. What is involved in processing someone's request for a ride, and and what happens during that time frame. So, on the one hand, there's like the algorithm that you use for matching passengers, right? So like, let's say you have some great algorithm for matching passengers to riders, and right now all it does is it like compares the passenger to every rider, or sorry, compares the possible passenger to every driver in your database, right? So, maybe this is okay, but if you have like 10,000 drivers, it's going to take a while to go through everything. Maybe you can come up with a faster algorithm that like keeps like an active cache of like what drivers are available right now that don't have any other passengers, or aren't taking an off day today or something like this. And so instead of having to search through 10,000, now you only have to search through like 200 or something, and match it up accordingly. Okay, so you're looking to optimize your algorithm in some fashion. So you do this process, and you come with the best algorithm that you possibly can, but then your fellow rideshare competitor is still able to be faster than you whenever you're requesting a ride. And you're like, well, why is this happening? And you're reasonably confident that your algorithm is the best that it can be. So maybe you took some leeway and you decided to you decided to somehow implement this process in a manner that's conducive to a faster development cycle, but is not so great for efficiency of your process. And what I'm really trying to get at here is, like, for example, let's say you write. Let's go back to the Sudoku solver example. You wrote it first in Python, and now you want to make it a lot faster. And you figure out, okay, well, I can't just run this through the Python interpreter and expect to get a very good speed up. I'm going to have to, go down and run this on the machine natively. So you realize you have to compile this code somehow. And so you decide, okay, well, I'm not going to try to compile Python. That's not going to work out so well. I'm going to go try to compile C++ instead. And so you rewrite this thing. And so similarly here, maybe our rideshare company realizes, oh no, I wrote this service in Python, which was great. It was really nice. Like I could do all this stuff, but now no matter how much faster I make my algorithm, the algorithm itself, like the actual code that I write, still has to be interpreted by the Python interpreter. And this takes a long time. And so I need to go out and I need to figure out how I can get my code to run on the machine directly, rather than having to sit on the interpreter, right? Which is a great realization to have, but think about what this means if you're a company of like 5,000 people, 10,000 people or more, and you have many of these services, right? You can't just stop the world and say, okay, we're going to rewrite everything to C++, because this is going to take months, if not years, right? And like, what are you going to do in the meantime? Are you just going to wait while your competitor boosts you off in features, or your customers get upset that bugs aren't getting fixed and other things that they'd like to see aren't happening? Probably not. It's not going to, it's not going to sound great to your bosses or your boss's bosses or anything like this, right? So there's a fine line in the corporate space for this kind of thing. When you're working on a really large scale, now it's kind of difficult, to be like, okay, well, the solution that we came up with some time ago that seemed okay in the moment isn't working for us anymore. Let's just like rewrite everything to fit this new thing that we have, that we believe will work better for what we're currently dealing with, right? So you can't do it, one, because you can't stop the world, and two, because, well, what happens 2 years from now when what your situation is currently is very different from what it's going to be in another 2 years, and you have to rewrite it again, right? And so this is this idea of accumulating debt over time. You have this debt from things that you did far ago that you have to pay off somehow, but it's not so obvious how to do it. Okay, so the maybe this is kind of a long setup, but the idea I want to convey now is sometimes there does become a critical point where these companies are like, all right, you know what? Like we did this thing, we thought it was a good idea in the past, like we spent a lot of time researching and planning whatever, but we messed up. And we need to, we really need to do like a full 180 and go do something else now, right? Because that's just not the way that the world's going to work anymore, at least for what we're trying to do. So now we can get to why I had this tab open. So in the past, Google used to write all of their web applications in pure JavaScript, right? And so let me open up an example real quick. Okay, so what's the deal with JavaScript, right? The thing is, it's a really nice language in the sense that, you know, if you have some idea of how you want to do something, let's say I want to do like, I don't know, I want like a function that like adds two numbers, like, all right, great. I can just say, you know, this function add that takes an A and a B, all it does is return A plus B, right? And if you write this in C++, like it's a little bit more of a mess in the sense that you have to do like these declaration of parameter types and stuff like that. And maybe you're like, oh, like this is a nuisance. I don't want to have to deal with this. The other nice thing is like, you know, there's a lot of like these implicit conversions that can help you out in some cases where you might want them. So like, let's say someone gives you like a string as an input. So I don't know, like they give you a string as an input, but you're like, okay, well, I always expect that what they're going to give me is a number. So even though the input is a string, you know that it looks like a number. And so you can say like, okay, well, forget about me like trying to parse the string and like, you know, try to explicitly do the conversion. Like I can just take whatever they gave me and do some operation on it. So like maybe, you know, you always want to add 5 to whatever a user gives you for whatever reason, right? So this is obviously very, this is a very toy example, but I hope the idea makes sense, right? So this is maybe part of the reason why, like, you know, you might prefer writing Python to C++ in your coding interviews or just in general, right? Because it's kind of just a little bit faster to do different kinds of things. Now, the problem with this is that, you know, once you get to a larger scale, it's a little bit more difficult to reason about what complex applications are doing, right? So like, for example, let's say I have, you know, some function that's like create person, all right? And so we're gonna give the person a name. We'll give them height, and we'll give them like an eye color, okay? So now let's say like I write this and I add it to my, you know, to my project or whatever. And I know how this thing works in here, right? So it's like somehow there's something that happens in here and I know what it does and I know what all these things are supposed to be. And let's say like Jane comes along and Jane is like, okay, like I want to create a person. So Jane's like, all right, I'll create a person. I'll call them Adil. Okay, well, what like what is this height thing, right? Like, what is this supposed to mean? Is this meters? Is this like feet and inches? Is it like it's not so clear just from this name height, right? So then, you know, Jane comes back to me and she's like, well, can you elaborate on what this height thing is? I said, all right, well, you know, it's centimeters, right? And so you do this kind of thing, and so you kind of you try to create some naming convention. but I hope that the idea is clear now. Like it's not so obvious what is meant to be specified here just implicitly by the name. It would be a lot more convenient in some circumstances, especially if you're dealing with people that aren't very familiar with what's going on, to provide them some more information about what needs to be done. And so there's two ways that you can do this, right? Like, you know, the two obvious ways are either you use a typed language where you specify these things as types, or you add a bunch of comments, right? So the problem with comments, right, is that like let's say like I had a comment here that's like height in centimeters. Like the problem with this is that if I later on change my implementation so that I use inches instead, then I have to change this comment as well, and maybe it's hard for me to keep track of all that. So Google was like, all right, you know, we're going to do something kind of in the middle. We're going to create like this like superset of JavaScript where you specify you specify like the type of your parameters in the comments, and then we'll create a compiler that like checks this information for you and make sure that make sure like the program that you write is like sound in some manner, right? Make sure that like all these types actually line up, and so that way, like if you do change your implementation, then it will yell at you and say, hey, like, well, you can't treat inches like this. And you have to say, oh, shoot, I need to update this comment that specifies the type of this information, you know, to be whatever thing else that I'm treating as height now, right? And so this is a real compiler that they have. They created a superset of JavaScript that uses these comments that specify types. The compiler reads that JavaScript, checks to make sure that all the types and stuff are correct, and then compiles it to very optimized JavaScript code. So this is not just a type checker. This is a real compiler. So in that sense, it's very powerful. Now, the thing with this is that no one outside of Google was interested in this, to be quite frank, like almost nobody at all. And Google has realized this, and the folks at Google were like, man, you know, we're putting so much time into this thing that we use all across all our web applications, but it costs us a lot of money, and no one else outside of us uses it. And so whenever we hire someone else new, you know, we have to teach them this entire new superset of JavaScript, basically. And also, like, we're starting to move away from what the industry standard is. And so does anyone know like what the industry standard is to deal with this problem in JavaScript today, where like it's, you know, it's not so easy to scale this very dynamic sense of JavaScript without having types? Anyone know what the new fun thing on the block is now? Yeah, yeah, right. So it's TypeScript, exactly. So yeah, so TypeScript like came out in the early 2010s from Microsoft, but it's really only exploded since like 2017, 2018. And you know, it is just JavaScript. Like you can write any function that you can write in JavaScript. Like I can take my add example from before, but you know, I can also. This is giving you an error, but you can turn this off. This is just basically saying you haven't typed this thing, so I don't know what it is. But you can inline kind of type annotations and say, okay, well, I expect these things to be numbers, something like this, right? And so the really great thing is that like this has blown up in popularity, and so people that are in this industry know what TypeScript is, and many people have learned it. And so it really has proven this use case that, okay, we're going to take this very dynamic language, JavaScript, which like has a lot of these powerful features that make it very easy for development, but it fails in certain aspects, including the scalability aspect for larger teams that we just discussed, because you know, you don't have this additional information giving people more context about what things are expected in their software. And it's very difficult to manage that kind of inconsistency without some kind of automated checker, like a type checker that makes sure that types are okay in the program. So TypeScript has filled this void, and also it's been very successful in the software industry, and it's taken this role as like a sound alternative for larger groups that need to deal with JavaScript on large scales, and it certainly has done a lot better than Clojure in that aspect. And Google introduced TypeScript to their code base like around 2015, and teams are slowly starting to adapt it. But I think that's something that is really powerful to show is that let's see, when was this? In early 2020, they started a team that is now working on a project that's set to finish in 2025 to convert all of their JavaScript code to TypeScript, right? Which is kind of a crazy thing to think about. They said, okay, we're not going to stop the world, but we're going to put people to work on something for 5 years. 5 years, it's a crazy amount of time, right? We're going to put them to work on something for 5 years to convert all of our JavaScript to TypeScript code, because we know that's the future. We know that like we made a mistake in the past with like the technologies we chose, but how can you foresee that, right? Like in another universe, maybe this thing did explode and this was the way to go forward. And yeah, so that's kind of one example that I want to share there is you need to kind of maybe what we can get from this is like it's nice to recognize like what is going to be the thing of the future, the thing that for people on Clojure team. Yeah, it is kind of sad, but they're not going away anytime soon. They still have a lot of work to do. As you can see, like they're still pretty active, right? Like this Nick Reed guy, it's an interesting guy. He pushed some commit an hour ago. But yeah, so I think for us, what it means is, maybe it's hard to see exactly what the future will hold and what will be like the hot thing or the good thing for us to invest our time in the future. But it certainly, I think, is a good idea to be diligent about it, and to spend some time actively researching and figuring out what is a good alternative to take, right? Because I think now certainly I think most people would say, all right, it's a good thing for me to try to use TypeScript over this Clojure compiler stuff in most use cases. Now that there's still some places where it's probably a better idea to use Clojure compiler, but we're not going to get into that right now. It's actually even better to use both of them, but that's kind of beside the point. The larger message I want to bring in overall is like, it's good to research the technologies you use, because it's not just like the architecture that you choose to design, it's what you make your software project up out of that is very important in the long run. Because if you choose the wrong thing, 5 years later, it might not be maintained, or there might not be other people working on it, or even who even know this technology. And then you have to spend a lot of time combing over and redoing all of your work, which again, individually might not be so bad, but on any team over 5 people, it's going to be a headache, because it's a lot of stuff to fix up, right? And you're kind of just spinning your wheels, not really making any new progress, but just re-implementing whatever you already have. Will they convert the JavaScript part of Clojure compiler to TypeScript? No. The answer is no. So what's going to happen at Google is, so if you know how TypeScript works, what it does is it takes this annotated JavaScript code and produces real JavaScript code from it, right? So this is some, maybe let's just do this example. This is some code that I wrote, and it spits out just JavaScript. But the thing is that TypeScript doesn't do any kind of optimization. It just does the type checking for you, make sure that everything makes sense more or less, and just basically removes the types more or less. I mean, there's some other stuff that it does, but that's basically it. It's not an optimizing compiler. Closure compiler, on the other hand, is very optimizing. They have some extremely aggressive optimizations that can speed up your code significantly. And so I think the plan at Google is to have everything in TypeScript, run it through the TypeScript compiler to check that the program makes sense, and then take the JavaScript that it outputs, run through this closure compiler to optimize everything, make it super small, make it super fast, and then that's the bundle that you end up with to send to the browser. Okay, so any questions on this first example, and then we can talk about some others that I have. But I know that was kind of a long-winded one, but maybe it gave you a perspective. Okay, so if not, like maybe we can talk about this one too. So I think this is kind of interesting. So Netflix has this blog, this like tech blog where they talk about I guess different issues and scaling problems that they have. So the thing is, like, Netflix for whatever reason like always has scalability issues, which makes sense because if you think about like the problem domain, it's kind of a crazy one. Like, first of all, you're dealing with video, which is like, do any of us really know anything about video? I feel like I don't know anything about video. I just know that it's a very difficult problem because these are massive files that you need to stream really, really quickly. So certainly it's a complicated issue, no doubt about it. And the second thing is that like you're dealing with a very, very distributed audience who are almost always on your platform, or people are always on Netflix. That's the first thing. And second of all, the traffic on Netflix has very, very large spikes, right? So if you think about what it means to run a streaming company like this, like, when are you going to get most of your traffic? Probably at like 6 or 7 p.m., right? When everyone comes home and they're looking to relax, and everyone decides to turn on their favorite TV show. Like all of a sudden, maybe like at 2 or 3 p.m., you had like 50% traffic because most people were like at work, and there's some people watching TV during class or something like this, or even at work or whatever. But then all of a sudden it shoots up like right as the day has ended, right? How do you deal with this? It's not such an easy problem without wasting a lot of money, right? So they talk about quite a lot of interesting things that kind of are all over the place, right? So here's like one about like growth engineering, which is how to psychologically siphon people into your company, basically. Optimizing data warehouse storage, right? All this kind of stuff. But one that I pulled up from 2015. So this is not the most recent, but I think it's kind of interesting to show like some tools that these kinds of companies use to kind of measure and have some sense of what's going on in their company, right? So basically the premise here that they talk about is like they have a bunch of these microservices that are responsible for different smaller parts of their applications. Like maybe they have like one service that's just responsible for authentication, one service that's responsible for like, I don't know, getting the movies that they should show as like the most popular in the United States right now or something like that, right? So instead of having like one giant monolithic application, there's like many different smaller applications responsible for smaller things, and they all talk to each other. And they say, okay, this is how we designed our system, presumably because like we have a lot of different teams working with each other, and we don't want them all to have to work on one giant application and like keep blocking each other. Maybe just have them work separately and then communicate through the network. And they say, okay, well, presumably some of these networks are going to be a lot more traffic heavy than others. How can we measure which ones are traffic heavy and which ones aren't? And they say, okay, well, first we'll try to do like a wide scale visualization, see how they all talk to each other, at what frequency, and they draw up like this kind of nice graph like this. I guess these names have been converted from what they really are in the company, but I don't really remember, because presumably I don't think they would have a service called Mike, to be honest. But you know, who knows Netflix? So they said, okay, we visualized like this, then like you know, this is maybe one thing that's helpful for us. Another thing that you can do is to draw kind of a bar graph like this. So what's happening here is just saying, you know, what is the traffic flow or the demand for my service across time. And so here you're measuring, like, I guess, what is this? Something like 10, 12 services over time. And they say, okay, you know, the thing that we really care about is are the bottlenecks that happen. Here's where it gets interesting, right? So they're saying, look, like, as time goes on, you know, most of our services, you know, don't really change too much in terms of their demand or their traffic, but some services have huge spikes at certain times, right? And so certainly here's where we want to invest our time and energy in to kind of deal with these problems, and figure out in an engineering fashion like how we can mitigate these spikes, right? And so I don't want to talk about the whole article here, but basically they say, okay, we saw these things, and then we were like looking into them a little bit more to kind of figure out like what exactly the real issue was, because it's actually not so clear to tell like whether this is like just because of user traffic, or maybe some kind of other artifact that's happening in your system. That's maybe not so obvious. And so they say, okay, well, you need to look at this stuff a little bit more, look at a lot of different metrics to figure out what's going on. And so the reason I bring this up is I think if you read this article, and I'll send it in the Slack later, I think what it's really, you know, one thing that I think it tries to express is the fact that like when you're working on these kinds of these systems or these projects, oftentimes the interactions are very convoluted and very complicated, and it takes a lot of effort to figure out what is going on a deeper level than just like, okay, like, you know, I send this request like from this service to this service, and you know it hops around and eventually just reaches the end user. There's also a question of like, okay, well, what are the other requests that are coming into a service at the same time? Does this, you know, does that force like a deprioritization of one request versus another, which makes like one slower than another or something? Are there any race conditions involved here? Are there any problems regarding like the utilization of one server versus another? Maybe one server is running two services at the same time. Well, if one of those services is very highly trafficked, it might slow the other one down, right? These are kind of very difficult things to measure and reason about as humans, I think, because I think in our minds, we are usually best at just handling one or two things at a time, rather than being very good at being able to juggle 10 different complaining factors all at once. And the point I want to make is that there is a very, very large need to invest in these kinds of tools that give you a good idea of what is happening in your application or in your service visually, because certainly I think, you know, we all have heard this adage thousands of times that it tells you 1,000 words, but it really is true. Like, certainly I have a lot, at least for me, I have a lot easier time looking at this kind of graph and being able to infer something about it than I would if you handed me a spreadsheet with all these data points. Now, maybe I could come to the same conclusion, but I think it's a lot more immediate to look at a picture like this and just see a spike right here, rather than looking at a spreadsheet and saying, oh, hey, I see a discontinuity between this data point right here, which is at like, 1/2 or 1, and this data point right here, which is at 3, very different from the continuity that I saw between the previous two data points. So the message here is invest in some visualization tools, get a good idea of what your service is doing, not just on one dimension, in the sense that like, okay, here's the traffic that I have, or here's the number of requests that I was able to do. You need to get some kind of appreciation for like, how are all the different things in my application working together, and what kind of consequences am I seeing from their interaction altogether, in terms of latency, in terms of utilization of all all the servers that I have for whatever is going on, et cetera, et cetera. So visualization is really important. I think both individually and like at a company level, when you're working with multiple different people, and having a deep understanding of the holistic view of a service that you have is very, very important. And certainly Netflix wouldn't be writing a blog about it if it wasn't at least important for them, I think. Yeah, so any questions on this one?
When companies are sort of tracing all of these requests and the number of requests, how are they doing this? Are they including some sort of functionality when they're writing each application in order to trace like the number of requests in the future? Or do they have some sort of additional software that they use to measure the number of requests going between the services?
Yeah, great question. So usually what is done is, let's say you have a company and you have a bunch of these microservices. Usually what you'll have is like each microservice starts off with like a basic template. And this template includes like some of this core functionality that does this kind of stuff. So maybe like it hooks up the service like onto the internal network. And also what it does is it provides like a very basic logging library that logs all this kind of stuff for you into a central repository so you can see this kind of information. So let's see. There's certainly some open source ones. Okay, so maybe let's take. It's not that good.
Is it basically like on every request they're logging the fact that the request occurred, or like?
Yeah. I mean that's it exactly. I wanted to find some example to show that like this is something that has been spent a lot of time on, but yeah, that's it exactly. What they'll do is they'll have some kind of logging and instrumentation library built in that keeps track of the requests that come in. And maybe you have some kind of server endpoint that you want to make sure that you have logging information for. You can build these kinds of very lightweight logging facilities that anytime someone hits your endpoint, like maybe asynchronously, will record that it was hit at this time or something like that. So it doesn't interfere with the actual work that needs to be done, but we do get like a record of it so that we can use it for these visualization and metric purposes, as we saw here. Does that answer your question?
It does, yeah. Thank you.
Okay. Okay, cool. Maybe so. Let me talk about one more. This will be kind of a fast one to wrap this up. Um, so this kind of differs a little bit from what we were talking about before with web applications and stuff, but this is about scaling uh, machine learning workflows. So maybe this will be some interest to you folks if you're interested in that kind of space. And if not, I think it's kind of just an interesting story. So Lyft, which is this rideshare company, they compete with Uber and other folks like that. In the past, what they had, so I guess first of all, I'll explain really quickly why they need machine learning models in the first place. The reason they need it is so that they can predict what prices they should give to their customers or consumers, right? Because it depends a lot on like what region you're working in. Like obviously the prices in San Francisco versus Madison, Wisconsin are probably going to be different. It depends how many, how many passengers are on at one time. It depends like what day it is. Like Christmas probably be more expensive than like, the middle of October, just because there's like more demand and more need for rideshare at those times. So there are kind of these complex like economic factors and environmental factors that go into making a decision that maybe aren't so easy to measure, that maybe aren't so obvious to measure directly, like using like a linear model or something that you build once, right? So Lyft had a bunch of these machine learning models that the data scientists would write to kind of try to predict this kind of stuff. And it would be very ad hoc. Like the data scientist each data scientist would kind of just sit down at their machine, open up Jupyter Notebook or whatever else they wanted to use, write their machine learning model, like build it on their machine, and then be like, okay, like I'm done. Here you go, engineer. Like put this into your, put this into your server, and you'll have something that spits out, prices whenever you ask for them. So I hope maybe it's kind of obvious like where this could go wrong, right? There's lots of different aspects, right? Like one is like how do you standardize the way that inputs are being fed to this model? This is kind of the same problem as you have when you're in a language like JavaScript, right? Maybe every data scientist does it a little bit different. Then you're kind of in this mess of like, well, if I take a model from this data scientist and you switch it out with this model from this data scientist, like how do I do that very well without having to like rewrite a lot of code to like handle their inputs differently? The other problem is like, maybe the outputs are different. Another problem is, maybe this data scientist machine is slower than this one. And so, she's able to build more models more quickly than this individual is, and so on and so forth. And so Lyft decided, all right, this is too much. This is not going to go anywhere. And so they developed this software called Flight, which kind of centralizes this this process of making machine learning workflows and creating models through them. And so indeed, instead of having every data scientist kind of make a model on their own, they kind of created this like centralized process for developing machine learning models in a central framework and that we distributed across different machines, so that you could, if you're trying to build one model, you could have like 10 machines working on it at once. And so obviously it's going to be a lot faster than if you try to do it all at once. And it can integrate very well with other software that they had in the company. So like this has like a nice Python interface, so you can talk to it efficiently through your Python code instead of someone just handing you a binary model and saying, okay, like go out and like create your own patchwork interface to talk to it, right? So the reason I bring this up is like this is another example, I think, where again, if it's just like one or two people, it certainly makes sense for you and I to just sit down and write our models in Jupyter Notebook and compile them into binaries and just plug them into our server. We don't need anything complicated because it's just you and I working. But at a much larger scale, it's no longer feasible to have everyone kind of doing their own thing in kind of their own unique, quirky, esoteric way. It's a lot more practical to design these centralized and common frameworks to have everyone do their own thing. And if you're interested in this, I would suggest checking Flight out. It is kind of an interesting project. It works decently well. There are some problems that I believe Lyft is dealing with now, in terms of the availability of the platform. It's not always the most stable, but if you're working on a team, certainly this kind of thing is very useful. And so what I would say, kind of to wrap this up very quickly, is like, look for places where you can automate your work. You don't want to automate everything because it doesn't make sense to generalize everything. You might spend more time trying to generalize something than it is just to do it, right? Like you're probably not going to write like a system that like automates uploading PDFs to Brightspace. You could do that, but it's probably a lot faster for you in the long term to just upload a PDF to Brightspace when you submit your homework, rather than like spending, I don't know, like whatever, 10 hours like putting a program that does that for you, right? The marginal benefit is astronomically low, but does it make sense to create a service like Brightspace rather than having everyone like mail in their homework to their professor? Maybe, right? So this is kind of one instance of that in an interesting field that's kind of been blowing up recently, which is this machine learning space. So yeah, I'll stop there. If you have any questions, let me know. And if not, thank you for listening to me for the past 5 weeks. I hope you got something out of it. And yeah, if you have any, anything else, like feel free to email me or just we can chat in the Slack, things like that. And yeah, fill out this feedback form that Ilya sent in the chat with this last very informal session.
Thank you.
Yeah, take care.